Welcome viewers. How do we find the diameter CE? I want to demonstrate to you the best method of obtaining the diameter without using congruence or the Thales theorem. Now, here we have a circle, a circumscribed circle, and our triangle here is the triangle ABC. Now, the angle at vertex A will just denote as angle A. So remember, the opposite side of angle A is the side CB, which will denote by small a, being that it is the opposite side of angle A. Then when we are at vertex B, if we denote that by just angle B, then the opposite side of angle B is the line AC, which we will denote by small b. Then when we are at vertex C, then if at vertex C we have angle C, then the opposite side of angle C is the line AB, which will denote by small c. Now, here we'll just need to get one angle only, or the ratio of one angle. So if you are given three sides and you are looking for one angle, then you use the cosine rule. So if we want to get angle A, then we'll start with A squared to be equals to B squared plus C squared minus 2BC cos A. So you can see A squared. If you go back to our diagram, A will be given to be 13. So A squared will be 13 squared to be equals to B squared. If you go back to the diagram, B will be given to be 15. So to be equals to 15 squared plus C squared. If you go back to the diagram, the line C will be given to be 14. That is 14 squared, then minus 2BC. So what is 2 times B times C? That is 2 times B we have is 15 times C we have is 14. So 2 times B times C is 420. So it is minus 2BC, which is minus 420 cos A. So if we rearrange negative 420 cos A coming on the left hand side of the equation, it will be positive 420 cos A to be equals to 15 squared plus 14 squared. Now plus 13 squared going on the other side of the equation, it will be minus 13 squared. So what do we get there? 15 squared plus 14 squared minus 13 squared. So we have it is 252. So here we are going to have 420 cos A is equals to 250 and 52. So what is cos A? We will divide both sides by 400 and 420. So if we divide both sides by 420, 420 will cancel with 420. We will remain with cos A to be equals to 252 divided by 420. 252 divided by 420. And we get that to be 3 over 5. Now, if cos A is 3 over 5, then it means that sine A is 4 over 5. Why? Because cos is always adjacent over hypotenuse, and sine is always opposite over hypotenuse, meaning our hypotenuse is 5, adjacent is 3. So according to Pythagoras theorem, hypotenuse squared is opposite squared plus adjacent squared. So hypotenuse we have as 5, so it means 5 squared is equals to opposite squared plus adjacent, which we have as 3 plus 3 squared. So there you'll get opposite will be the square root of 5 squared minus 3 squared. Then you get the opposite to be 4. Then sine A is now opposite of 4 over 5. That is how to get sine A. Or in other words, when you have cos A to be equals to 3 over 5, then it implies that A is the cos inverse of 3 over 5. So that when you are now looking for sine A, it is going to be the sine of the cos inverse of 3 over 5. And what do you get there? What is the sine of the cos inverse of 3 over 5? What is that? You get 4 over 5. So it means whichever reasoning you use, you still get sine A to be 4 over 5. Now, having found sine A, then our work is done. Why? Because according to the sine rule, A over sine A is equals to B over sine B is equals to C over sine C, which is usually equivalent to 2r. If r is the radius of the circumscribed circle, and you can see 2r is always the diameter. So 2r is the diameter, and the diameter is what we are looking for, the diameter CE. So it means 2r is CCE. So what is CE? So we've seen to get CE, we only need A over sine A. And the side A from our diagram, you can see the side A is 13. Then divide by sine A. Sine A, we found sine A to be 4 over 5. So sine A, we found here to be 4 over 5. Then divide by 4 over 5. That means it is 13 times 5 divided by 4. So 13 times 5 divided by 4, you get 65 over 4. 65 over 4. And that gives you 16.25. So the diameter CE is 16.25. Ladies and gentlemen, that is the simplest mean to determine the diameter of a circle given a circumscribed circle using the cosine and the sine rule without using the Thales theorem and the congruences. Thank you for watching, and see you again in our next video. Don't forget to subscribe.